So hi guys, this is short video dedicated to the converse of Pythagoras theorem. You know, direct theorem tells you that if you have right angle triangle, so you stated that you have right angle triangle, you will have the following for sides a, b, and c. C squared equals a squared plus b squared. So the longest side that opposed to 90 degrees angle is equal to the sum of squares of two other sides, which is called legs. Okay, so what about the converse? The converse statement is the following. So you have a triangle and you have the statement that c squared is actually a squared plus b squared. So the outcome of this statement is that this angle opposed to C, the longest side, should be 90 degrees angle if this statement is fair. Okay, that's what it converse. So basically it tests whether your triangle is right angle, and it shows exactly where is the right angle. It should be opposed to the longest side, which is C in this case. Okay, so for example, let's test the following triangle with the sides. Say we have sides 8, 5, and 6. So we need to test whether there is right angle and this triangle is right angle or not. Okay, so we just simply need to put the longest side as C, that's always the case, and test this equality. So we still have the question because we need to test it. So okay, 64 equals 36 plus 25. Okay, so let's check it. It's not equal, obviously, hence the triangle is definitely not right angle. Okay, that's the typical question. It's pretty easier to understand how it works. Just basically test this equality for the sides, and if it's successful, it means as the right equality, it turns out to be identity, like one number equals to identical number. So hence you'll have 90 degrees angle somewhere opposed actually to the longest side. Okay, but however, so probably you might have troubleshoots if you're stated that you have surds. For example, let's say square root of 27, square root of 48, and let's say square root of 75. So everywhere you have surds, right? So let's test. You understand that in order to do, if you have a calculator, so no problem, just evaluate each square root and give the value. But it's obviously the more the under root expression, the more the value of the resultant square root. So I bet that 75 is going to be the longest side here, so it's going to be C. Okay, let's test it. So take calculator machine and take the square root of everything. Okay, square root of 75 is equal to square root of 84 is equal to, and square root of 27 is equal to. Okay, I won't waste my time, so it's up to you guys. But I gave you methodology, so how to cope with that. So actually look at the under root expression, and 74 obviously more than either 48 or 27. So this is the longest side, okay? So now we just need to test our equation c squared equals a squared plus b squared. So instead of all variables, we just plug the sides. Let's say this is a and this is b, so we just plug there to test if this equality is correct. Okay, so let's see, 75, because square root squared means you just simply get rid of. So one more time, this is the main property of surds, or if you're not sure, just go back to index topic. We have indices, so you'll have always a under root expression. So we'll test 75 whether equal to 48 plus 27. Okay, so 8 and 7, 15, and 60. All right, yeah, it works. So that's why this angle is 90 degrees, because your equality is correct. Okay, but what if you have like square root of, you know, fractional number, and each side is basically less than 1? For example, let's take this triangle and see how it works. For example, say 0.4, 0, 2, 1, and say 0.22. Okay, so let's see how it works. It works pretty the same. You just want to test the highest value. If you have 0.4, then you're taking a square root. So now let's say calculator and see. What if you have, let's say, 0.4? So this number, obviously under root expression 0.4 is obviously more than 0.21. But let's compare how it works with the roots. So take calculator and evaluate, and let's see the result. So if you take calculator and evaluate square root of 0.4, so let's say you have 0.6. You see your number after square up, it raises in its value. I'll explain in a minute why is it happening. So let's take about square root of 0.21. Now let's take 0.21. So it's also raised up, and it gives you the value 0.4, let's say 58. Okay, but if you round up to 2dp, you'll get 0.46. Okay, you understand that anyway here you'll get higher number when the higher root when it higher under expression under root expression. So in this case it's 0.4, it's more than 0.21. But let's compare probably let's say very close values. So 0.3 and let's say square root of 0.4. So let's take 0.3 square root and still get less value than you have in 0.4. Okay, so it will give you 0.55. So that actually is still less than 0.63. So anyway, the logic works in the same manner. So the greater under root expression, so the greater, say the greater the square root of 8. So you just simply need to get rid of square roots and just compare what you have in the under root expression. Okay, so obviously it doesn't work, because if you get rid of square roots and 0.4 is the longest side, so you test whether it's right angle or not. So you take 0.4, square it up, and you will get just 0.4 because you square up square root, and means you get rid of. And on the right side you will have the sum of two squares, but actually it becomes under root expression. Okay, so this value is greater than 0.4, so that's why you don't have the right equality. Okay, now the question, why fractional number after the square root gives a value more than it was previously? I mean, why it's rising? However, we've seen before that, for example, if you take square root of 64, you'll obviously get smaller expression than under the root. In case of fraction which less than 1, you'll get increasing in value. So let's discover this paradox. So 0.4, and we actually taking the square root of it. So if you consider like square root of 4 over square root of 10, because yes, we're eligible to do that, convert into ordinary fraction. So let's see what's happening. So we diminish the value for numerator, okay, it's 2. While we also do the same with, let's say, denominator, okay. Now we have square root of 10. So we can approximate, I mean, we can put a very close value that we know. Let's say square root of 9. Yes, it's very close to 10. And even if we estimate, we'll have the value that's equal. So this value is equal to 2 over 3. So let's see what happened. You have square root of 4 over square root of 10. Yes, and under root expression were in ratio like 4 to 10 somehow, right? And now let's see what you arrive to. The difference in numerator and denominator becomes less, right, than it was originally. So let's say difference 5 here if you compare numerator and denominator, and now it becomes only 1. Even if you take precise value for square root of 10, so we'll give you square root of 10, we'll give you 3 point something, 3.16, and still somewhere around 1.16. So the difference is diminished, right? And what can you say about the fraction? What happens in terms of, is the value greater than just it was before? Obviously, because now numerator and denominator are very close to each other, right? So that's why the value of the fraction actually increased. That's the paradox revealed. Why if you take in square root of expressions or numbers that less than 1, it basically will generate the value that's greater than under the square root expression, okay? While it works vice versa, if you have numbers more than 1, like square root of 64, it always diminishes the value, right? In comparison with the previous 64, so now it's 8 only. Okay, so obviously you understand how to test it. But what if, finally, what if you have sort of mixed numbers and or like surds, and you have like whole numbers, for example? Let's check this. Square root of 24, let's say 5, and let's say 7. How to understand which value is the greatest in order to start writing this statement. Okay, and if you don't have calculator, so obviously you need to estimate. In this case, if you don't have any calculator, you need to say that square root of 24 is a bit less than square root of square number. Okay, the closest square number is 25, so which is 5. So you can say that the top estimation or the upper estimation, upper bound for your square root of 24 is 5, and lower bound, if you estimate the nearest value that's square, is square root of 16, right? So you just simply place your 24 in between two square numbers. So one more time, write this. Okay, so 24 is very close to 25 and is obviously more than 16. Then you take the square root, because you know how to work out, because they are square numbers, you'll get your estimation. So you'll get square root of 24 is between 4 and 5. Now you're pretty sure that square root of 24 is not more than 5 and even 7. So this is the smallest value, okay? The smallest. In order to prove, to check your statement about c squared equals a squared plus b squared, you simply need to say that so 7 is going to be the greatest number. All right, so let's put it and check it. So 49, which is 7, that's c, equals to a squared, let's say it's 5, so a is 5, so 25 plus square root of 24 is just 24. Okay, and you see this is the right equality. So equality is correct because it's also 49. So 49 is identical to 49. All right, so that means the angle that is opposed to the longest side, in this case C, is 90 degrees. Okay, so actually that's all except for probably the last task is considered the last problem. So for example, let's say you're given a triangle and you have the height from this apex. So remember, apex is the point where you put the height down to the opposite side. So this is, let's say, height, okay? Means this 90 degrees angle. All right, so you give the values, say this 6, so this 4, and this 9, okay? So, okay, what do you need to find? You need to establish whether the right angle, whether this triangle, let's mark it as OPN, so triangle, whether triangle OPN is a right angle. So that's the question. So you need to test, is it 90 degrees angle within the triangle? Okay, so how to work it out? Obviously, you need to figure out the size, because in order to check, so you need to calculate OP and you need to calculate PM, because you know that your ON, so I'll put the questions here because they're candidates that we're looking for, because you know that ON is actually 9 plus 4, right? Which is 13. All right, so how to work OP value? Just have a look at the left side triangle. So from the triangle OP, and say we mark the letter K, OPK, we know it's right angle because PK is the height, so we can figure out Pythagoras, which looks like OP squared equals 9 squared plus 6 squared, because the longest side is always opposed to 90 degrees angles here. Okay, so let's figure out. So it's going to be OP squared equals to 81 plus 36. So, and we'll get, so 26 as 116, 117, right? That what we have for OP squared. And in order to find OP, we just simply need to take square root of it. So OP square root of 117. All right. So next one, PN. So for PN, we'll use the right hand side yellow triangle, which is also 90 degrees, means right angle triangle. So from P triangle, P, K, N, we can figure out the value for PN. So PN squared is actually 6 squared plus 4 squared. And we'll get the value for PN is square root of, so 6 squared is 36, so 4 squared is 16, and we'll arrive to 52. Okay, now we know all the values. And now we need to check that square root of 17 squared and square root of 52 squared is actually 13 squared. All right, so let's check it. So 9 plus 4 means 13. So I'll just write c squared equals a squared plus b squared and just plug the numbers. So the longest side is 13 equals to square root of 117 squared, so we'll get 117, and then we add 52. All right, so 13 squared, it means 169, but you can use a calculator to check it. But actually, if you're given square numbers, that will be not the problem for you. Okay, and we actually trying to add up the right sides. So 117 and 52. So we'll get 169. So yes, this equality is correct. So this triangle, the whole OPN is 90 degrees. So the answer is yes. Okay, that was application. And actually, so next we'll go to problem solving relating to Pythagoras. we just try to cover the maximum possible class, and after that we'll go to the circles and circles problems, basically like sort of angles in the circle and how we can apply Pythagoras there. Okay, so for challengers actually who are looking for more complicated problems, just check out my videos that related to challenge problems. That's basically GCSE Maths higher tier or extended, so just check them out and try to solve. Okay, that will be good practice for you guys. Okay, thanks, and up to the next videos.